8791. Some turbine-powered aircraft have a fuel temperature indicator in the cockpit too. A. Monitor the fuel flow in the event that ice crystals form in the fuel system. B. Monitor the fuel temperature during high-altitude flight. C. Ascertain the amount of fuel on board the aircraft when ice starts to form in the fuel tanks. The correct answer is B. The fuel temperature indicator in the cockpit of turbine-powered aircraft is primarily used to monitor the fuel temperature during high-altitude flight. At high altitudes, where the outside air temperature is extremely cold, the fuel temperature can decrease significantly. Monitoring the fuel temperature is important because extremely cold fuel can lead to issues such as fuel crystallization or waxing, which can clog fuel filters or fuel lines and impede fuel flow to the engine. By having a fuel temperature indicator in the cockpit, pilots can monitor the temperature and take appropriate action if it approaches or falls below critical thresholds. The option mentioning monitoring the fuel flow in the event of ice crystals forming in the fuel system is not directly related to the purpose of a fuel temperature indicator. While ice crystals in the fuel system can pose a problem, monitoring the fuel temperature alone does not provide information about the presence of ice crystals. Additional systems, such as fuel system icing detectors, are typically used to detect and mitigate ice crystal formation. The option stating ascertaining the amount of fuel on board the aircraft when ice starts to form in the fuel tanks is not accurate. A fuel temperature indicator does not provide information about the amount of fuel on board the aircraft. Fuel quantity is typically monitored through separate fuel quantity gauges or systems. 8792. When inspecting a fuel system, you should check all valves located downstream of boost pumps with the pumps. A. At idle. B. Dormant. C. Operating. The correct answer is C. When inspecting a fuel system, it is recommended to check all valves located downstream of boost pumps with the pumps operating. The reason for this is that the valves should be inspected under normal operating conditions to ensure they are functioning properly and allowing the correct fuel flow. By inspecting the valves while the boost pumps are operating, you can verify that the valves open and close as intended and that there are no restrictions or malfunctions in the fuel flow path. This ensures that the fuel system is operating optimally and that there are no issues with the valves impeding the proper flow of fuel. Inspecting the valves with the boost pumps at idle or dormant would not provide an accurate assessment of their functionality during normal operation. It is essential to observe their behavior under actual operating conditions to identify any potential problems or abnormalities. 8794. On a large aircraft pressure refueling system, a pressure refueling receptacle and control panel will permit one person to A. Fuel or defuel any of the tanks on an aircraft. B. Fuel any of the tanks on an aircraft. C. Defuel any of the tanks on an aircraft. The correct answer is A. In large aircraft, the pressure fueling systems are comprised of a refueling receptacle along with a control panel and gauge cluster. This setup allows a single individual to easily fuel or defuel any or all of the aircraft's fuel tanks. 8795. When routing a fuel line between two rigidly mounted fittings, the line should A. Have at least one bend between such fittings. B. Be a straight length of tubing and clamped to the aircraft structure. C. Have a flexible line added between two metal lines to allow for ease of installation. The correct answer is A. It is crucial to avoid installing a straight section of tubing between two firmly mounted fittings. Instead, it is recommended to include at least one bend between such fittings. This bend serves to absorb any strain resulting from vibration and fluctuations in temperature. 8796. Which of the following tests can determine an aviation gasoline's tendency to vapor lock? A. Reid vapor pressure test. B. Octane vapor pressure test. C. True vapor pressure test. The correct answer is A. The Reid vapor pressure, RVP, test is used to determine the volatility and vapor pressure characteristics of aviation gasoline. Vapor lock is a phenomenon that occurs when the fuel vaporizes too easily, leading to fuel flow interruptions or engine performance issues. The RVP test measures the pressure exerted by the vapor of the fuel at a specified temperature. It provides an indication of the fuel's tendency to vaporize and form vapor bubbles, which can cause vapor lock in the fuel system.